So we're going to learn decimal expansion of rational numbers. Every rational number can be expressed in a decimal form, or every rational number has its own decimal equivalent. Now let us try expressing 7 by 8 in the decimal form. 7 divided by 8. You have to place a decimal. So 0. Point. A 0 can be added now. 8 8s 64. Remainder 6. A 0. 8 7s 56. Remainder 4. One more 0. So far it's clear. 8 8s are 64. The remainder is 6. So add a 0. 8 7s are 56. The remainder is 40, and now 8 5s are 40, 0. So your remainder is 0. So what is this decimal equivalent? It's terminating. So 7 by 8 has a terminating decimal expansion. 0.875 is a terminating decimal. What do you mean by a terminating decimal? You have a definite answer and the remainder is 0. Now, one more example to prove to understand decimal expansion. Minus 17 by 8. Let us try dividing this. Minus 17 by 8, keep the negative sign. Let us divide 17, 8. 8 to 16, 1. Of course, when you divide, you place a decimal here. 10.18. Remainder 2. A 0. 16. Remainder 4. Now 40. 8 5s 40. So 17 by 8 also has a terminating decimal equivalent. So decimal expansion of minus 17 by 8 is minus 2.125, which is also a terminating decimal. Now what is the other kind of decimal? Non-terminating decimals. It can also be non-terminating. The decimal expansion can also be non-terminating. Now, non-terminating decimals, there can be two types. It can be non-terminating recurring or non-terminating non-recurring. We'll see about this in the next video. So, we saw that when the decimal equivalent terminates or when it comes to an end with the remainder 0, we call it the terminating decimals. Now, let us see examples for non-terminating decimals. 8 by 3. 8, 3. 3 to 6. Remainder 2. Now, you will have to add a decimal point. 0. 3 6, 18. 2. Once again, the process keeps repeating. Again you get a remainder of 0 and this goes on. Is there an end to this? Because the remainder is again 2? No, there is no end to this. So how do we represent these decimals? 8 by 3 is equal to 2.6666 and so on, which is equal to, how do we represent it? 2.6. These decimals are called non-terminating repeating decimals. You may also call them as non-terminating recurring decimals. They are represented by putting a bar over the first block of the repeating part. You can omit the others. If you put a bar over the first number, 6, the 6 is the repeating part here. You put a bar over it, you can omit the other numbers, and this bar implies that 6 keeps repeating. We'll see more examples of non-terminating repeating decimals in our next video.